thing actually for this year and for future courses that you take. This word function, you've heard the word function before, but not in terms of the mathematical definition or how it's used in math. There's a few websites we're going to use. Actually, it's the same website. It sounds pretty exciting because it's called hotmath.com. And I'm just pointing that out now so that I'm giving credit to them for the things I'm going to use here. Okay? So what a function is, first we're going to spend a little bit of time on, or most of what we're going to spend our time on today is the concept of a function. Okay? It isn't going to be that you're going to learn, here's how to do a bunch of stuff, here's how to solve this, here's how to do that. The first thing we're going to look at is just the concept of a function before we get to any numbers or anything like that. All right? Then we're going to talk about, well, if you know what a function is, how do you tell what it isn't? So then we're going to talk about functions versus non-functions. And then rolled in with that is something called the vertical line test. It's part of how to tell if something's a function or not. But so if you want to fill in this part up here, the focus on, right, the objectives, understanding the concept of what a function is, deciding whether a relation is what do you think goes in those two blanks? Deciding whether a relation is a function or a non-function. And using what notation? Function notation. It's good when it's fill in the blanks and all of them are filled in with the same word. So what do you think the last one's function? Graphing functions? No. Graphing, what most of Math 10 you focus on a specific type of function. What do you think that is? Starts with L, linear, right? We focus on linear functions. So first things first is what a function is, the concept of a function. Okay, this picture over here. A function is the mathematical definition of the word function is just some kind of a rule that takes an input and gives you an output. And the rule is applied the same way to whatever input you put in. We can come up with some simple ones, okay? It's almost like the best model is to think of a function as a machine. I mean, obviously when we get further, we're not going to think about it as a machine, and that's where this website's going to come in. But take a number, put it in, and see what number comes out, and then there's some kind of a rule that changes the number. So, like, the rule could be lots of different things here, right? The rule could be you put a number in, whatever number comes in, you multiply by 4, and then you add 11. So if you put in a number like 0, if you put 0 in, what's going to come out the bottom? Because you multiply by 4, you get 0, and you add 11, you get 11. Or if you put 1 in here, you put 1 in, you multiply by 4, you get 4, you add 11, you get 15. Or you put a 2 in, you might be able to see a pattern eventually, right? A lot of functions will see a pattern. You're going to get 19, and then you put in a 3 maybe, and you get 23, right? You could keep going. I just picked a few inputs here, but you could put a lot of different things. There's a lot of different ways you can represent a function. You can represent it with words. This is with words. You can represent it with a table like this. You can represent it with a graph, which we're going to get to. You can represent it with an equation. These ones over here, here's an equation. All right? What I want to do with you is show you this hot math site and see what you. It's math and it's hot, so it's called hot math. See, we're going to put a rule in here, and then we're going to put some numbers in and see what comes out. Okay, so we'll start with a pretty simple rule. The simple rule is, let's take the x value. So the inputs are called x here, right? The inputs are called x. The outputs are called y. It's going to put it into a table here after, right? You put some inputs here, but we're going to write a rule, and we have to write it as an equation here. we are going to say take the x value and do what to it? Give me an operation that I could do here. What could I do? Take the x value and but let's do adding or subtracting. Plus 12? Plus, how about just plus 2? Okay, that's our rule. We're going to put a number in. Give me a number to put in. 5. Let's stick to small numbers so it fits on the graph. What about if I put in, what's another number to put in?
7.
Let's put in numbers to stick to the graph. So look at the graph and let's try and fit on the graph. 9? Oh, fancy, the graph changes. Wow. 2? Uh-oh, 92? Oh, I messed it up. It changes, though, so it doesn't matter. Give me another number. Let's not make it any bigger than it already is. 5. Oh, no. Because you have to go backspace? What kind of crazy thing is this? Okay, fine. No undo? Okay, fine. Okay, 500, but must do backspace. 400. It doesn't actually matter how big we go here because 300. Where are all these things going to be? Where are they all ending up? They're ending up on a line. I wish we hadn't made the number so big, but because it's hard to see down in the bottom there where it is, but we'll do another one after. If I sat here doing all these numbers and just kept putting numbers on here, what am I going to end up with? Let's say we sat here for 3 hours putting numbers on there. You're going to get a whole bunch of dots, but they're always going to be on that straight line, right? I guess I should point on the screen, right? Whole bunch of dots. They're all going to be on this straight line here. Okay? If you had it keep going here and just keep putting numbers, it would create this straight line. What about if I had put, this is hard to tell what the pattern is in the table because we put the numbers in sort of a random order. So let's put the numbers in an order that maybe is more organized here. So we're going to put the same function in here, but now we're going to put 0. Actually, let's put -3. See how it changes. Let's put -2. Because you can put negatives, right? Let's put -1. And let's put, what would be the next one that makes sense? -0. So you can see the pattern in the graph. You can see the pattern in the table, hopefully. Let's do a couple more, and then we can look at all what's happening here. 3, 4. It's very exciting, I know. Well, I mean, if you had a spreadsheet or something, you could go faster. But okay, so we got a bunch of different representations of this function. This is a function. I haven't told you why it's a function or what a function is yet, but this is a function. It's a relationship between these two numbers, x and y. It's a linear function. In grade 8 and probably in grade 9, you looked at what made something a linear function. From the graph, how can we tell that it's a linear function? Because it's a straight line. How can you tell from this that it's a linear function? This goes up by, it's not that it goes up by 1, it's that it goes up, every time this goes up by a certain amount, this goes up by the same amount. Not the same amount, but a constant amount. This goes up by 1, and that goes up by 1. And this goes up by 1, this goes up by 1. Every time you go up by 1 this way, it goes up by the same amount that way. If suddenly you went over 1 and then you went up 2, and you went over 1 and you went up 3, and then you went over 1 and you went down 5, that wouldn't be a linear function. If these are constant jumps here, the change in x and the change in y are related to each other. Okay, let's do a different function here. Let's get wild and crazy with the hot math here. How about if we take x and we times it by 2, and then we subtract, and then we add 1. How about that? Can we do that? It's going to write it in a stupid way there. What would be the better way to write that? Write 2x, right? You're okay with 2x means 2x plus 1. It means times by 2, add 1, right? I'm going to start at 0 here. What's 0 going to give me? It's going to give you a 1, right? Anytime you put 0 in for x, it gives you the starting value. You're going to learn later on that that's what this number is. If you put an extra number in an equation like this, that's the initial value, the starting value. That's where it starts on the y-axis. If I put in 1, it's going to be 3. If I put in 2, it's going to be 5. If I put in 3, we don't want to get too many here, 7. If I put in 0.5, that one's trickier, but where is it going to end up? It's going to be 2, right? Because 0.5 times that is 1 plus 1, but it's still going to be on that line, okay? You fill in that line will get filled in. Every time, and then what if I put in, let's say here, 4, and then what if I skip 1, and I put 6? It's all on that straight line there. Let's look at a couple points here. Every time I jump up by 1, what does this jump up by? 2. That's what a linear function is. Jump up by 1, this jumps by 2. Up 1, or, this goes by 1, this goes by 2. On the graph, what that means is you go over 1, up 2. Over 1, up 2. Over 1, up 2. This doesn't, with the points I have here, this goes over 2, and it goes up 4. That's still a straight line because proportionally it's the same. Going up 2 for every 1 is the same as going up 4 for every 2, right? Anyways, these are both linear functions. If I want to make it a non-linear function, I have to put something where I have a squared, or I have something like this. I'm going to put x squared. The way you do that on computers is you put this little thing above the 6 key on a keyboard. Okay, that thing means to the power of when you're doing mathematical stuff, and it'll even change it on here to write it that way. I will show you that this is not a linear function, because if you put 0 in, you get 0. If you put 1 in, you get 1 squared is 1. But if you put 2 in, what am I going to get? 2? I'm going to get 4, right? That's not a linear function. Already you can tell because this goes over 1, up 1. It goes over 1, but then up 3. The vertical change is different for the same horizontal change. That's why it's not a linear function. If I put in another number here, okay, if I put in 3, it's going to be 9. If I put in a negative, you'll really see that it's not a linear function, negative 1. What does negative 1 do? Negative 1, you square a negative, becomes positive, right? Negative 1 gives you positive 1. Positive 1 gives you positive 1. This is actually a function you look at in grade 11. This is called a quadratic function. It's not a linear function. It's called a quadratic function. It is one that you again, either course you take, if you take Foundations 11 or Pre-Calculus 11, you're going to look at this. This is called a parabola, this shape. It's a parabolic shape. There's a lot of things that involve parabolic shapes. Satellite dishes, cables of bridges. You launch something into the air, it travels in a parabolic shape. That shape comes up all over the place. Anyways, that's not a linear function. In your textbook, you're not going to find a lot with non-linear functions. We're going to do a little bit of a game here. Okay, here's a game though. For this thing, you don't get to see what the rule is. Okay, but you get to see the values. I'll show you the table. I won't show you the graph. I'll show you the table, okay? You can, first of all, we're going to do it where I'm putting them up here, and you're competing with the person next to you. Okay? And the way you're going to do this is you're going to, the goal is to try and guess what the rule is in as few numbers as possible, as few pairs of numbers as possible. Okay? Actually, we could do this collaboratively at first. You could work with the person next to you. or well, it's up to you then. You could work with the person next to you and make it a cooperative game, or you could work against the person next to you, or you could just kind of watch and try and get it yourself, even if there's nobody next to you. Okay, so what I'm saying here is, let's say I put a 0 in. Don't say it out loud. I'm not looking for the first person. I just want you to, I'll go with a few numbers and you can have the satisfaction of knowing how few it took for you to guess what it is. You have to be able to write the formula. Afterwards, I'll ask for someone to give us what they think it is. We'll put it in and test it. Don't say it out loud. Just talk to the person next to you. If you think you know what it is, you can write it down. Okay, are we okay? Oh, I was going to show you the table, right? 0 gives you 3. How about if we do 4?
Oh, I got it.
Are you looking and doing this? Okay, got to be trying. Don't. I'm not looking for the first person to tell me. I'm going to put a few more numbers till people can get it, okay? Let's just pause this. Here's another number.
Yeah.
8. I'll make it easy for you. I'll go in the same amount here. You want another one?
Oh, no, we're good.
12. You predict what you think what it's going to be for 12 if you think you know the rule. Don't say it out loud. Just predict it for yourself.
Are you going to do 12?
I'm going to do 12. You're predicting? You have a prediction in your head? What's your prediction?
Here, pick me. Pick me.
That's your prediction? Your prediction of the rule is x plus 3? Test it.
16.
That's correct. That's the graph. Why do you think they show that line there instead of just dots? To show that it's linear.
To show that it's
But what else?
continuous step.
What if I put another number in here like 2, one that I didn't do? Where is it going to be? On the line. The line shows you where all the points are going to be. When you draw a line for a graph, you're saying it's all the points. This is all the possible points. Okay? Because you don't want to draw a million little points in here. This is saying this is all the points. Okay? If you put a 2 in here and you hit that, it's going to be right there, right? Okay, it's on the line. We're going to go to the next one here. I don't think they ramped this up difficulty-wise very quickly, but we'll see, okay? I didn't make up hotmath.com, okay? So I do not control the difficulty of hot math.
No, it's making the equation.
I'm not making the equation, it's making it. It's running this, okay? You ready? If you didn't play last time, you need to play this time. I'm going to give you a 2. I'm not going to start you with 0. It's harder when you don't have the 0 given. Okay? 2 gives you 2. Okay? Now don't... Okay, does anybody know what it is yet? What could it be for that? Give me one thing it could be for that. What could it be? 2x minus 2, because twice that much minus 2. It could be that. Give me something else it could be. What did you say? Somebody said it over here.
X.
It could just be y equals x, right? It could just say y equals x, because then whatever you put in for x, that's what you get for y. Any others it could be? Could be
Y equals 2.
it could be y equals 2. That's good. You're right. It could be y equals 2, and then whatever I put in for x, y is 2, right? So we're going to put one more in here. Let's put in, we won't make it totally easy right away. We'll put in one that's not right beside it. Okay, now don't shout anything out.
Wow.
When you only have one pair of numbers, you can't figure out what it is. When you have two pair of numbers, if you know it's linear, you can figure out what it is. All you need is two pairs to make sure to say that it's linear. Are we? I think we've narrowed it down that it's not a couple of the things you just told me. What? Yeah, what is it? It's looking a lot like it's do a big number. Okay, like 11. 11's a big number. Oh, look, it's still 11. What do we think it is?
X equals Y equals X.
Y equals X. Test the rule. That is correct.
It's so easy.
Y equals X is this line. This is one that's worth learning. Directly, diagonally up like that. Let's see if they ramp this up at all here. Third one. Here's the third one. Let's go with a 2 to start with. Anybody want to guess it before I even put any numbers? Like the people that answer the Jeopardy question before he's even read the question or whatever? 7? You're guessing that it's 7? Well, I was thinking guess the rule, but can you imagine if it's 7? Oh, pretty close. Oh, 9. Anybody have an idea of what the rule could be there? It could be X plus 7. What's another rule it could be? It could be 2x plus 5, yeah? 3x plus 3. 4x plus 1. 5x minus 1. How many rules could you come up with for this if we only have 1 point? Imagine on the graph, if you have 1 point, there's a whole bunch of lines that could go through that. There's an infinite number of lines that could go through that. If you have another point, then there's only one rule it can be. Let's put another point in here like 5. 5 is 15. That's tricky, isn't it? It's tricky. You guys can think of what it is. You think about what it is there. I will pause this while you're thinking. I know some of you right before said, can we just do our homework instead of this? And I realize that might be a good thing, but I think you're going to learn a lot by participating in this. For those of you, again, I don't want to publish your names on YouTube that you're not participating, but the whole world will know you're slackers then. The few of you. Here, whoops, I forgot to start that again. If you think you know what it is, I'm going to give you one more number and you can confirm your rule here. I will give you, I was going to give you a number that really helps you figure out what it is 0. 0 is a good number to work with. If you want to test your theory here, we know what it is then? Somebody could tell us what is our rule? You tell me. 2x plus 5. That's it. Good for you. Awesome. Okay? You're gonna find out that 2x plus 5, if the rule is 2x plus 5, when you put in 0, it gives you 5. Okay? Anyways, should we try one more? No. I hate this. I hate everything. Okay, we're going to test our rule here, show the table. Okay. Now, can we get the rule from this? Come up with a possible rule or a couple possible rules for yourself. Come up with a couple possible rules there. Don't say them out loud yet. If you think you have a possible rule, remember there's a whole bunch it could be, right? Because you could have a line that goes up to the right, you could have a line that goes down to the right, you could have a line that goes straight across, you could have a lot of different things. I'm going to put one other number in here, and it's going to be 5. How many people think they have the answer right now? Good, you got it? Should we try one more? Okay. If your number's right, who said they had it right over here? Give me a pair of numbers then that it should be. Give me an X and tell me what the Y should be before I put it in. 10 should be? 10 should be what? 10 should be 34?
34. It's right. It's gonna be
Okay.
that, yeah.
Okay, can you think about what your rule is then? Anybody else think about what the rule is? Let me give you another one to help if you want. 20 should be
64.
64. 0 should be
4.
4. Oh. Who would invent? Listen, I mean, I know I've been promoting this hot math thing here, but this is a great website, whoever invented hot math, but don't you think you should have it where that automatically goes back like that? I mean, come on. Maybe there's a reason they left it sitting there. They didn't expect slow people like me that it would take so long to learn that you have to backspace to get rid of it. But what should 0 be? I said it should be 4. Okay. What's the rule? Somebody different who hasn't said anything. What's the rule? Who hasn't said anything?
X times 3 plus 4.
3x plus 4. Test the rule. That is correct.
Can we do something harder?
Well, it's its own thing here. Okay. It's controlling what it's coming up with. I am going to leave that. I'm going to leave that there. We can do that after. I'm going to pause this. You don't have to do all 8 of these right now. I know some of you are the kind of people that don't like leaving things undone. Some of you leave things undone and you don't seem to mind that at all. But you don't have to do all these questions. You have to pick one of them. Okay? Here's the one you have to do. You have to do this one. You have to fill in the table. And this one I would like you to do the opposite. From the table, you come up with the rule. Can I have everybody refocus here for a second? You only need to do those 2 questions. If you weren't listening, I guess you have to do them all. After you've done that, this is what I would like you to do. I would like you to play that function guessing game with the person next to you. Okay? Here's how you play. You put up some kind of a divider between you. You take a piece of paper. One person you each make up a rule and then you just take turns. Like one person makes up a rule, they say it's 5x minus 7. And then the other person doesn't see that. The other person makes a table like this. Are you listening? The other person makes a table like that, and even a graph if they think it helps. You guess numbers. So you say 0 gives me the other person. You say 0. The other person has to tell you the number. They don't tell you the rule, they tell you the number. So for this one it would be minus 7. Then the other person guesses another number. And they tell you the number. Okay? Minus 2, right? And then they tell you another number. You can do whatever you want. You should make up rules that involve a couple operations. If you want to start with one that only involves one operation, like you could do 5 times x, those are going to be things you're going to guess pretty easily, though. As soon as you involve a multiplying and an adding or subtracting, or even if you want to get wild and crazy, a dividing, like x divided by 2 plus 3 or something like that. You need to involve multiplying or dividing and adding or subtracting. 2 operations. Does everybody understand the game?
Yes. Can you do that?
If you listen, I understand that for 7 months now you've been showing up, and mostly what I give you is, work on paper to do. And sometimes some of you just sit there staring at the walls or doing nothing. If I've given you a game, I know it's a math game, I get it, but if I'm giving you a game to do here, and you're still just staring at the walls, I'm pretty much going to give up hope for you, okay? You need to participate. I think you're going to learn more doing this, especially if you're kind of the person that stared at the walls for the other stuff. Try doing this, okay? One person makes up the rule but doesn't tell the other person what it is. The other person guesses numbers. Here's how you keep score if you like to keep score, if you don't just like playing for the sake of playing. If person A makes up the rule, person B starts guessing. Hey, listen. At some point, person B says, I think I know the rule. Person B says, is the rule, like let's say after 2 guesses, person B knows the rule. They say, I think it's x times 5 minus 7. If they guess it here, person A gets 2 points, right? Because what you want to do is keep the other person's score low, right? You don't get 2 points because you guessed it in 2. Like your goal is to have well, actually we could do it that way. You could have where you have the lowest score possible. Let's do it that way. It's like golf. You want to have a low score, okay? If you guess it in 2, you get 2, but you want your score to be low, right? Because if it takes you 10, you're not doing very well at it, right? The only what if is, what if the person guesses wrong? What if they say I know it and they guess wrong? Who gets a wrong guess? If B makes a wrong guess, where do we put points? What's that? No, you get to keep guessing, but you got to add. How many should we add to their score? 2. It's plus 2 for a wrong guess. If you make a wrong guess, you add 2 to your score. The goal is to have a low score. Yes. What? What's the par? The par is, you're right. Par is 2 for each hole you play, or whatever. Okay. You have to try and you're challenging the other person. Okay, you ready? Get going. You have 10 minutes to play.
What if he does like crazy equation?
Yeah.
5 is 6.
Or the person could tell you a par. If it's a really crazy equation, you could say it's a par 4.
5, I guess